The income from a group of vending machines is a continuous income stream with an annual rate of flow at time t years from now, given by f of t equals 12e to the negative 0.4 t. This should be in thousands of dollars per year, okay, because it's a rate. So we want to find the present value of income from these machines over the next 5 years, if money could be invested at an annual rate of 6% compounded continuously. So we're going to use our typical slicing approach. So I'm going to take the 5-year time interval that they're asking me about, 0 to 5, and slice it up into little tiny time intervals, each one having a constant deposit amount on it. So I'm going to pick a generic time t, a tiny little time interval, delta t. So I'm just looking at this small interval of time. Okay, so on that interval, the amount deposited in this small time interval is f of t dollars per year times delta t years. So your years cancel and you get f of t delta t dollars. So we know that on any given time interval, a tiny time interval that starts at time t, we're investing f of t delta t dollars. So to find the present value of that tiny little time slice, the present value of my time slice is f of t delta t, the amount of money we're investing, and because it's compounding continuously, it's e to the negative 0.06 t, because it's 6% compounded continuously. So that's the present value formula for an amount of money, and our amount of money is f of t delta t dollars. So then what I'm going to do is add up all my slices, so the present value total, it's the sum of all my slices that look like f of t, which maybe I'll start writing the formula now, which is 12e to the negative 0.4 t, and then times e to the negative 0.06 t delta t. Put the delta t at the end as a convention. We're doing this from I equals 1 to infinity. Each of these t's are actually t sub i's. If you go back to the picture, this is a generic t sub I. T1, T2, T3, I'm adding them all up. And then I take the limit as n goes to infinity. Oops, that should have been an n there. And that translates to an integral. This is the integral from 0 to 5 of 12e to the negative 0.46 t dt. So I added the negative 0.4 and the negative 0.06 because those are like bases, you add the exponents. And this comes out to approximately 23.47. And that's in thousands of dollars. So 23,470. What is the present value of all the income that could be earned from these machines over the next 100 years? The setup for this is exactly the same, so I'm not going to write out all the slicing parts again. I'm just going to jump to the integral. It's just instead of going from 0 to 5, I'm going to go 0 to 100. 12e to the negative 0.46 t dt, and that comes out to approximately 26.087. Again, that's in thousands of dollars, so this is $26,087. And if we were to do this for 1,000 years, you would see that the answer actually doesn't even change that much. So quickly just add a 0 here. Oops, I didn't add a 0. There we go. Still 26.087. So that is our limiting value for these vending machines. The present value over a long, long time is $26,087. So that would be the fair price of those vending machines. If you were to sell those vending machines today, their present value is $26,087. So that's the exact fair price. $20,000 is not a fair price to the seller, because to the seller, they're worth more than that. $30,000 is not a fair price to the buyer, because to the buyer, they're not worth that much. So neither 20,000 nor 30,000 is a fair price. The exact fair price is $26,087.